Talk for a few minutes about trends in first ionization energies as we go up and across or down and across the periodic table. And we're going to start with going across the periodic table. And what I want you to notice as we go from left, we'll look at the n equals 2 level, and as we go from left to right, from lithium to neon, you'll notice the general trend is for the ionization energy to increase. And this is logical because as we move from left to right across the periodic table, the effective nuclear charge increases. The greater effective nuclear charge holds the electrons more tightly, and therefore it's harder to remove those electrons because they're held more tightly. You'll notice a couple of variations from that general trend, and I want to talk about why those are. For both lithium and beryllium, we're removing the 2s electrons. When we jump up to boron, however, the third entry in this line, you'll notice that it goes down a little. That's because we're removing the 2p electron. The 2p electron excuse me, is a little bit further away from the nucleus, held a little bit less tightly because it's a little bit less close to the nucleus. Now as we go to carbon, again less effective nuclear charge, held less tightly, easier to remove. As we go to the next element, nitrogen, also lower effective nuclear charge, held less tightly, easier to remove the electron. You'll notice then when we jump to oxygen, we get a slight decrease in in ionization energy. And the reason for that is when we fill these first three, boron, carbon, and nitrogen, we're putting the electron unpaired in each of the p orbitals, px, py, and pz. When we get to the next element, the oxygen, we now have two of the electrons paired. And there's a little bit of electron repulsion when we start pairing these electrons, making that electron held a little bit less tightly and a little bit easier to remove. As we look going down the periodic table from lithium to sodium to potassium to rubidium, the general trend, or on the other hand from helium to neon to argon to krypton to xenon, the general trend is for the ionization energy to get lower as you go down the periodic table. And that's because as you go down the periodic table, the n level of the electron you're removing is greater, meaning it's further from the nucleus, held less tightly, easier to remove. So the only real exceptions we have to worry about to our general expectations are when we shift from the s subshell to the p subshell and when we start pairing electrons.